My name is Tong Liang En from National Tsinghua University. Today, I will present my final project title, AUFL Sum Enhancing Unsynchronized Unsupervised Federal Learning with Self-Organizing Maps. This work focuses on improving clustering stability in asynchronous and unsupervised federal learning setting by introducing a structured representation based on SOM. In many real-world applications, data are distributed across multiple heterogeneous clients, such as edge device or sensor. In this project, we consider an unsupervised setting where no labeled data are available, and clients upload their model update asynchronously. In addition, the data distribution are often uneven and non-IID. This combination of asynchronous and heterogeneity makes federal clustering particularly challenging and often lead to unstable learning behavior. Asynchronous unsupervised federal learning, or AUFL, is designed to handle decentralized and unsupervised data. Each client performs local unsupervised learning using its provided data and update to the server asynchronously. The server then aggregates these updates to form a global clustering model. However, under uneven data distribution, AUFL is sensitive to noisy or biased update, which can cause unstable convergence. To address the instability of AUFL, we introduce the self-organized maps. Some preserve neighborhood and topological structure and represent cluster using multiple nodes rather than a single central. This property allows some to smooth the aggregation process under asynchronous and noise update. The key idea is use some as a structural representation to stabilize global clustering in AUFL. The slide illustrates the intuition behind a self-organizing map. At the beginning, sum consists of a regular grid of nodes in the future space. Each data sample attracts its closed node together with neighboring nodes on the grid. Over time, the grid deforms and adapts to the underlying data distribution. As a result, nearby nodes represent similar data, and the global structure of the data is preserved on the grid. Based on this intuition, we integrate sum to AUFL framework. Client first perform local unsupervised updates and upload sum asynchronously to the server. The server then maps incoming update to some node. Aggregation is performed through some structure update, which helps stabilize the global clustering process. To further analyze the role of sum, we consider two variants of AUFL sum. In AUFL sum fully replaces the original bin label aggregation. In AUFL sum partial, sum replace the bin weighting step followed by data weighting. This compression allows us to isolate the structural contribution of sum in asynchronous federal clustering. In this experiment, we compare AUFL sum and AUFL sum partial. The performance is evaluated using four metrics: objective value, VI, RI, and ARI. And this is a response to various rank index and adjust rank index. All experiments are conducted under uneven and asynchronous client setting. These four figures summarize the overall performance comprehension. Across different metrics, AUFL sum generally show more stable behavior than the original AUFL. In particular, the AUFL sum partial already provides noticeable improvement, indicating the benefit of sum's structural smoothing. The AUFL sum further enhances robustness in most settings. In conclusion, this project demonstrates that integrating sum into AUFL improves clustering stability under unsynchronous and heterogeneous settings. This partial variant highlights the structural role of the sum, while the full variant further enhance the robustness. Future work include adaptive sum topology and more principal weighting strategy. Thank you for your attention.